All right, today is 12th March, and we are reviewing a new paper. Since my current work is being stuck on evaluations part, I would trying to explore the space. So let us quickly go over this. This paper is suggested by a Twitter friend actually. So yeah, effective evaluation of large language models in an open challenge in NLP researchers. In NLP, researchers and engineers face methodology issues such as the sensitivity of the models to evaluate effective evaluation of large language models in many open challenges in NLP, researchers and engineers face methodology issues such as the sensitivity of the models to evaluation, such as difficulty of proper comparison across methods and the lack of flexibility in this paper. We draw on 3 years of experience in evaluating large language models and provide guidance and lessons for researchers. First, we evaluate an overview of common challenges faced in language models evaluation. Second, we delineate best practice for lessening the impact of these challenges and research. Third, we present the language models evaluation harness, that is this open source library for independent participant extension evaluation that seeks to address these issues. We then describe this is we describe the features of the library as well as case studies in which evaluation research should be important task is crucial to is to track and communicate progress in machine learning. Evaluation and shared benchmark task is a crucial task is to track and communicate progress in the machine. Evaluation and shared benchmarks. Evaluation and shared benchmark task is a crucial tool is to track and communicate progress in machine learning. Aspects are used to track progress towards check community goals and when they implement the newly proposed methods or power-based evaluation practices. First, we task evaluation research period. Frequently struggle to reproduce the results reported in various papers as well as carry out the evaluation ourselves. To address this problem, we have built a large language evaluation harness, a flexible evaluation library that serves as a research infrastructure evaluation on board with LME values to enable researchers to run any value, any benchmark on any model as easily as possible while also making it easy for creators of new model references libraries and evaluation which wanted to make their work through a broad ecosystem. Over the past 3 years, the design of LME has evolved as the need of the open source community and our understanding of best practices in language model evaluation have evolved. In this paper, we detail lessons learned that have been especially beneficial, broken, and useful in particular findings. We highlight several common faced challenges in evaluating language models, including the difficulty of assessing the correctness of natural language responses, challenges in management design, and their independence upon implementation details that are often obscured or unreported. We then discuss the best practices we've identified to improve how to communicate results and improve evaluation regarding the language modeling community. Despite this challenges section, finally we detail how we use learning to inform the design of challenges evaluating and scoring natural language abilities. The biggest challenge in natural language in a language model evaluation is conceptual and the key problem when evaluating language models. There can be many semantically but equivalent but syntactically different values of expression. It's just that there can be many same idea. This is actually the main. There can be many semantically equivalent but syntactically different ways of expressing the same idea. In any ideal world, we would have a way to automatically detect when two sentences express the same content but in different words. Unfortunately, our best tools for determining whether two sentences are semantically equivalent are the very models we are seeking to evaluate. This problem drives many of the approaches to LM benchmarking, and many problems with LM evaluation stem from there not being any silver bullets for solving the key problem. In principle, This would be solvable by simply having expert human ardor to score more points for correctness. The main reason this is not obstacle because performing accurately human studies is not only difficult and time consuming but also very expensive due to fair competition. Pricing smaller actors or organizations are performing such evaluation. Additionally, there are other reasons relying on some human system must be done with caution. They can be flawed and biased, especially for complex judgments such as factuality. Expert trained human judgment can alleviate these issues but is inherently non-scalable. Because the high cost of the manual metric are often automated metrics are often used. These offer notable advantages in that they are theoretically fully reproducible, far easier and cheaper to communicate, and can avoid some of the issues faced by human studies. Automated metrics such as Blue Raw seem to directly solve the key problems by measuring distance from generative response to cold standard ones such as via counting the n-gram overlap, counting the okay, so this issue sticks based methods such as blue and its derivative have flaws and present reproducibility challenge but can be useful. More recently, model-based metrics have recently gained momentum through evaluation metrics that leverage large language models greater, especially as proxies for human, but they are also known to be flawed and suffer from similar reproducible issues and the key problem can alternatively be so the key problem can alternatively side steps by artificially restricting the answer space. The most prevalent way to achieve this is to reframe questions as multiple choice questions with a single golden target. Okay. Alternative when reference access is known, one can perform string matching approach restricted to determine whether the model's answer matches the ground truth. Challenge does not necessarily impact other applications of spelling games where it easy to check the game has any more constraints. Scientific applications or domains where you practically usable verifiers even when the solutions are not checkable in our context. In the case of LLMs, the most notable cases where this ground truth verifier is known as are coding mathematics although the verifiers used just test based in edge cases. Benchmark design environment. Typically, we do not care about actual numeric scores of a model on a benchmark. Instead, we desire the benchmark to be a useful proxy for some real-world phenomenon. The validity of an evaluation is the extent to which these correlate. For a recent overview of validity concerning NLP benchmarking, also see this over extended discussion of construct validity in evaluation. While validity is an ongoing problem in LM evaluation, we focus on mitigating other concerns first as we will describe LM eval is designed to ensure measurements are consistent across the runs of models regardless of validity. This is due to our goal of building research infrastructure for evaluation. While we as researchers prefer some evaluation benchmarks to others, our goal is to enable researchers to run any evaluation benchmarks or any model. Implementation difficulties and reproducibility. Once a benchmark has been designed, it has been needs to be implemented by evaluation researchers around the world to see user driving progress in the field. This introduces universal challenges that needs to be addressed in order to ensure that everyone is evaluating the model on the benchmark in the same fashion when comparing the even assuming that benchmarks are implemented consistently across the world, the question for fair comparisons across models and methods is still difficult. For instance, different instruction-tuned models may be trained to expect certain formats. Use these models instead can make the validation task very difficult or change the difficulty, but not using these. These can also bias against model trained with format not matching tasks standard prompting styles. Likewise, if an original benchmark implementation included prompting and processing instead for a specific model, other models trained differently will suffer, artificially skewing perceptions of what techniques are effective. Likewise, some questions of how to set up controlled experiments are still open. Is it ideal to normalize performance in comparisons by the number of parameters? Training of flops, inference costs much, must training data be held equal? How should models which can leverage external sources such as retrieve documents or external documents can be compared? These questions are all context dependent but can impact findings significantly. For example, explorers comparisons across architectures and training objectives and choose to normalize for flops. Thus, comparing encoder-decoder models with the double parameters to the decoder-only models, comparing the results with equivalent training, compare the results with equivalent training, flops regardless of the however in a more comparison with smart works and expensive and then fast changing orders. These benchmarks to illustrate the effective development shows how implemented the design shift. Always share a possible full validation code, including the full prompt use, should also be provided for the reproducible version as well as for other adaptive files such as links to specific commits used. Failing this sharing practice is often not done, but can just for fair comparison against other models. Evaluation should be done with the same set of prompts unless the executors do not do. Prompt should not be optimized for performance of a given model, but not others. The model of the prompt engineering should be disclosed. Avoid copying adjustment. Always provide model output. Providing model output along with the version code can allow others to recalculate scores based on these artifacts, which can be useful for performing statistical significance testing for the evaluation of larger model API and sharing. Finally, sharing outputs can allow increase to some extent. A small batch of the results and qualitatively review an output before testing at scale. It is very easy to find a bug in the issue, especially when you're quantitatively score only provides so much information. To understand why a model is scoring so well or so poorly, it is concepts of qualitative analysis. This is measured for the from by these practices we have built lexical evaluation or infant benchmarking libraries. The evaluation of C groups and then describe what the correct answer should. As a task class using a common API, this allows tasks to be collected in a common library for new tasks to be extended or implemented easily, and for novel tasks to be easily shared reproducibly among practitioners or other library users. Users can implement tasks easily via YAML-based configuration files or so data sources, the questions, structures, collect answers, prompt formatting, targets, requests, model output, calculation. The operation for my tasks objective just configured by YAML. Okay, the next piece of elimination is LMAPI because effective orchestration is request types. We allow for 3 code types: requests, log likelihood. We allow for 3 code type of device that may be sent to the which can be a distant measurement from measuring the average likelihood, log likelihood, or probability of producing the requisite given data set, generating text until a given stopping condition is reached for a more conditions or no much information, but okay. Until next time.